see.
GPS reveals what we can't see or feel, and the readings are disturbing. The ground here is moving.
This station is moving 3/4 of an inch a year, and that's because as the Juan de Fuca plate comes in under North America, the overlying North American plate is being dragged with it.
GPS shines a light on the incredible force. The movement varies, but on average, the region is being shoved eastward by 1.5 inches every year. It's a mammoth distance in geologic terms. Since Cascadia's last megaquake in 1700, the region has moved by as much as 39 feet. And the GPS shows something else. The coastline is moving faster than the land farther inland, causing the North American plate to buckle. A 600-mile strip is being squeezed.
The crust is getting compressed, literally just like a spring. And when the fault that's driving all of this compression then breaks, that it will be the earthquake, then the spring unloads and everything launches back.
The locked zone between the plates releases, and suddenly, and without warning, a chunk of land the size of Ireland lurches more than 30 feet. Both the land underfoot and waters out to sea roil and pitch with epic fury.
If you're in downtown Seattle and the earthquake happens, you will find that you have moved towards the southwest between, say, 3 and 5 meters. And if you're out on the coast, you'll find you've also moved to the southwest, but probably more like 5 to 10 meters.
Land along the coast, pushed up by the fault over 3 centuries, collapses. As the plates break free, it may also unleash one of the most devastating events: a tsunami.
It causes the water above that seafloor to be lifted up, and then it collapses under its own weight and flows toward land and across the Pacific Ocean.
The tsunami could be as high as 50 feet, tall enough to wipe entire towns off the map. The Cascadia fault line is beginning to reveal the titanic forces at play. But one question remains.
How close to the metropolitan regions does the fault actually slip and generate the seismic waves?
A chief worry has been that the megaquake will erupt within 100 miles of Seattle, the region's largest city. Now, new evidence shows it may hit much closer than that. Not far from Seattle, the fault is rumbling. The shifts aren't instantaneous as in an earthquake. They are very, very slow.
This fault that we all worry a lot about is not a dead, inanimate thing. It's actually very much alive.
About 50 miles inland from the coast, the North American and Juan de Fuca plates grind against each other. Melbourne follows these tremors on an underground instrument that continuously records the fault's movements.
Okay, Rex, so this is going to go down into the sand, keep it upright. Going to stick that into the data logger. We can actually see it in a minute-by-minute basis. Where is the Cascadia fault slipping? How much did it slip by in the last 12 hours?
The fault is not moving every day, but for specific short intervals every 14 months. The shifts are the first seismic events that experts have learned to predict here.
And they've come like clockwork every 14 months.
At Melbourne's lab in Central Washington University, data pour in from instruments all over the state. He's on the lookout for 2 things: signs of a larger event and how close the tremors come to Seattle. When he and Rex Flake map where the fault is moving, the news is ominous.
This one's only 170. Yeah, so this one's a good 60% bigger.
The lock zone of the fault, rather than stopping at the coast of Cascadia, it actually comes inland, at least in the Washington State region, by as much as about 50 miles.
The locked zones appear to extend much farther inland than previously thought. It makes for a much more powerful quake, much closer to where people live. And it could strike much closer to Seattle than anyone ever expected, threatening massive destruction.
You're talking about something that's tens of thousands of times the size in terms of energy release of any earthquake we've seen.
Seattle must now brace for a catastrophe its builders never anticipated. But it's not the only city facing this unwelcome news. In the middle of the continent, in America's heartland, another major quake may be building. Memphis, Tennessee is far from traditional earthquake country. Yet the ground here can move so violently, it can stop the mighty Mississippi River. That's what early settlers were shocked to witness in autumn of 1811. It is December when the shaking begins. It continues on and off for months.
There were 3 to 4 very large earthquakes. And in addition to that, there were thousands of aftershocks.
Witness accounts describe tremendous shaking that downs trees and chimneys, spanning 40,000 square miles, an area the size of Iceland. But at the epicenter, the scenes are apocalyptic.
They talk about large fissures opening up and water and sand fountaining out of the ground up to 30 feet in the air.
These geysers, these sand blows as they're called, covered the fields at the end of the event with lots and lots of sand and water, in some places as much as 3 feet, maybe more.
Before it's over, one large quake strikes beneath the Mississippi itself, uplifting the earth by tens of feet. Incredibly, the mighty river reverses course.
The uplifted land would have blocked the flow of the river and forced it temporarily to flow backwards.
The Mississippi has long since returned to its natural path, but the remnants of the sand geysers remain. Excavations of those geysers and hunts for hidden fault lines are exposing what happened here and what may await Memphis.
See how it resists?
Martisha Tuttle and Eugene Buddy Schweig see a disturbing record buried in fields. The quakes of 1811 and 12 were not flukes.
Nice.
They were just the latest in a series that stretches over hundreds, if not thousands of years.
This is the sand dike where the water and sand shot to the surface.
The earthquakes turned the wet, sandy soil into a liquid.
The water pressure between the sand grains starts increasing from the shaking until finally the sand grains are pushed apart so they're not touching each other anymore, and the material, instead of being just a layer of sand, starts behaving like a liquid.
Oh, yeah.
The quakes liquefy soil 20 or so feet underground. The increased pressure inside the liquefied soil forced it to seek an outlet. It erupted. But not all of the sand blows date to 1811 and 12. Many erupted earlier, revealing a pattern of shocks here in the heartland.
The older ones seem to cluster in age around 1450 AD and 900 AD, and indeed there are even some older than that. About every 500 years there seems to have been a major earthquake, indeed a sequence of earthquakes.
In a region of little other earthquake activity, thousands of miles from any continental plate boundary, this 500-year recurrence has rocked the field of earthquake science.
If you fly over the central part of the United States, all you see is a very quiet farmland. And so you don't see mountains, you don't see a fault scarp, you don't see anything.
What hidden forces generate these earthquakes?
I'm gonna try to catch it.
Beatrice Magnani of the University of Memphis is trying to expose them. With no faults visible on the surface, Magnani teaches her graduate students to look for fractures underground.
So we discovered a new fault. Nobody knew this fault existed, and it's located right here. Now the key is understanding when this fault moved last, right?
Not far from Memphis, the team hunts for fault lines by essentially taking an X-ray.
We're ready to shoot.
They use seismic waves, the same waves generated by an earthquake. The waves bounce off sediment below and return, where listening devices called geophones pick them up. The recordings reveal not just a single fault, but many.
We're finding that there are many faults that are concealed under the sediments of the Mississippi River.
It is an unusual phenomenon that geologists are struggling to understand. Like a worn carpet, the North American continent has a weak spot. Eons ago, the continent began to split apart. It failed, and the tear never healed completely, leaving a rift.
This rift now is sitting like a scar in the middle of the continent, and bounding this rift are large faults. It is believed that these faults are now being reactivated today, 500 million years later.
Scientists don't yet know why the faults move and generate earthquakes, but when one goes, it can trigger another close by.
That's probably why instead of having just one earthquake in 1811 and 12, we had multiple events, because there's so many faults breaking this area that after one large one breaks, it has to adjust itself on the other faults.
Memphis's builders never realized it, but they erected their city very close to a major fault system. Memphis, Tennessee is not braced for an earthquake. Yet if scientists are right, it may soon face a quake that could lay waste to the city and threaten the people who live there.
By some measures, actually, the hazard here is as high as in California. We say that a probability of around a magnitude 6 occurring in the next 50 years is probably something on the order of 80 or 90%.
The quakes that struck here in 1811 and 12 were even more powerful and blew sand from beneath over a vast area.
These features are so large that you can see them from the air.
The sand blows stretch over thousands of square miles. Only large earthquakes can liquefy soil over such a wide area.
I think they were very powerful earthquakes. at least one of them was on the order of a magnitude